So vanakkam. So we will continue our lecture on seismic instrumentation. So far we discussed about the earthquakes. Okay, so what is the seismic hazard and different type of seismic hazard we have seen. So then we also try to understand how the seismic events are occurring, where the earthquakes are occurring. So plate tectonics. So we also studied about the different type of earthquakes with respect to the energy released, where it occurs, depth. Okay, then followed by we also studied about the earthquake instrumentation, like how to record a earthquake. Okay, so how to measure what is the seismometer, seismoscope, how it works. Okay, we also discussed about the oldest seismic instrumentation of Chinese seismoscope also we discussed. So we studied that the different type of seismic instrument with respect to the period, okay, and then data it records. So we also seen the seismogram, accelerogram. So the accelerogram is basically instrument which records acceleration is the accelegraph. Okay, so where you can get a acceleration versus time. So general earthquake, so mostly it is recorded as a velocity versus time, which is called as a seismogram. Okay, so the instrument which records is seismograph. So this is the development. We have seen that the first seismic instrumentation was basically 1880. That is the first time where the seismic instrument has been released or invented in world. So even though there was a Chinese seismoscope, but which was not officially recording the any data, it only give you the direction of the earthquake. So as I told you in the last class, so you can Google it and find out how the seismoscope works, because there was a detailed X-ray based study where the oldest seismoscope, they basically took X-ray and tried to understand what mechanism it has been used, which was not breakthrough until 2018. Okay, so up to 2018 people are suspicious how it works, but after 2018 so they find out using the modern technology without breaking the equipment how the seismoscopes are working, what is the principle behind that. They are also explained that. So those who are interested to work on the seismic instrumentation or know about the seismic instrumentation building or developing the new seismoscope, so they can read those kind of things which will help you basically to come up with the new seismic instrument. So as I told you that India as on now nobody produces a seismic instruments to measure earthquake. Okay, so we all basically import several seismic instruments from abroad and it has been used. So we also seen that this seismic instrument located place is called as a seismic station. Okay, so we also seen what are the minimum requirement for the locating seismic instrument at particular place. So it should be free from any kind of cultural noise. It should not be located on the soft ground sites are not suitable. So then we have seen that there are three-way people maintaining the seismic network. So global network, national network and seismic array. Okay, so we studied that the global network is basically it is an instrument which is very broadband in nature, can able to record any earthquake occurring anywhere in the world. So it's very sensitive equipment. Generally each country at least one or two global network should be placed. So we also understand that this global network not only record the earthquake anywhere in the world, it also record a nuclear testing or any blasting happen in and around the world. Particularly the developed countries basically sponsor this kind of network to the developing countries and try to see what kind of activity is going on with respect to the nuclear testing or development. So we have also seen that this helped basically to detect even the Pokhran atomic testing by the Dr. Abdul Kalam in Rajasthan. Okay, so this is the because of the seismic instrumentation global network only they could able to identify there is a blasting happened. So and this was the energy released by this. So based on that they come to know that it is a because the energy released by the nuclear explosion, energy released by the another explosion will be completely different, and the area the felt and all those things will be completely different. So this data they used basically to know that we have tested atomic testing missile facilities kind of things. So after basically the global network, the next one is actually the regional network. So generally regional network has to be done for each region, so that you will know what is the depth of earthquake and as well as what is the magnitude it is, and then what are the active seismic sources, which will help to seismic hazard analysis, which we are going to discuss later stage. So the regional networks are very important to get a reliable prediction of earthquake hazard. How much magnitude going to happen, if that magnitude happens, how much the PGA you can expect. If the regional network is available, you can predict very precisely. Moreover, whenever you want to place important structures, so you need to know which are the places are seismically active, which are the places are non-seismically active. Those kind of information can be obtained from the regional network. So the another one is actually the array. So array is actually the number of stations, which is not similar to regional, but it is very small scale, where they try to understand how the wave propagation changes at a smaller scale. Okay, so for example, if there is a valley, ridges, okay, in the region with a different soil thickness, how the seismic wave changes from one point to other point, which has to be studied, and for the research point of view, this arrays plays a very important role to understand how the seismic wave propagation taking place, how the amplifications are taking place. Those are all the details you can get from the seismic array. So we also seen that there is a minimum number of stations required for a particular place. For example, the any azimuth should be in between the stations should be less than 180 degree, and then if the area and the spacing should be twice, less than twice of the depth of the earthquake in the region. So we have seen that what is the minimum requirement spacing for the this one, that you should remember. So that is a scenario where internationally people built or arrange or develop a seismic network, so that using that data one can predict a earthquake hazard, possible future earthquake forces, so that you can design your structures on that. So let us see what is our country status on seismic instrumentation. Okay. So if you look at India, so there was a lot of past earthquake damages reported in the literature. Okay, as I told you that there was a city called Pumbugar, even it has been washed away by the tsunami. Okay, it was maybe around 800 years back. So like that, there are many cases where the historic events are reported in our olden literature. So even the palm leaf literature, it has been written. But as per Indian seismic instrumentation concern, which was not very old as our earthquake history. Okay. So if you look at the earthquake study itself, the modern kind of study, or people with detailed understanding of seismic hazard, is started just about maybe 120-30 years back, not beyond that. So the prior to the seismic instrument development in the country, okay, so generally the GSI, which is part of the British government system, so used to engage to carry out the investigation of the soon after any large earthquake in the country during that period. So this was the oldest information we have in terms of the earthquake damage report, and then quantifying the earthquake. Okay, the quantification of earthquake we will be discussing in the next class, but to quantifying the earthquake. So this was basically GSI, Geological Survey of India, controlled by the British government, is involved on doing the field investigation in the large earthquake. Soon after earthquake, the member of GSI group will go there and do the site observations and report what are the damages are reported in that area, and based on that they can guess that what was the level of magnitude or level of earthquake it is. The first scientific study of Indian strong earthquake was carried out for the Kachar earthquake in 1869. Okay, so the Kachar earthquake by the 1869 by Dr. T. Oldham. So he was the first Director General of GSI. So his illustration of son of Dr. R.D. Oldham made a very thorough study on the Great Shillong earthquake in the 1867. So the first report was observed on the Kachar earthquake in 1869, then followed by there was in 1897 there was a big earthquake which is occurred in the Shillong region, which was studied by the Dr. R.D. Oldham. Okay. So, he was basically this Oldham, both are them the same family. The report of the 1897 earthquake, okay, the Oldham, it is published as a 1899 report, is classical work and great foundation for the present day modern seismology in India. So, that was the first earthquake where this study has been done in detail and people try to understand how the earthquake causes different seismic hazard parameters, okay, different seismic hazard like such as what we discussed was direct ground motion, ground deformation, amplification, liquefaction, landslide. So, these are all the hazard how it reported in the Shillong was been well described in the Oldham 1899 publication, which was carried out by the R.D. Oldham in soon after the 1897 earthquake. So, after occurrence of this great earthquake, okay, so in 1899, the necessity of installing seismogram in the country was very much felt by the British government. Then the Seismological Committee of British Association recommended installation of few seismogram in India in 1898. Okay, the Shillong earthquake is basically origin for the today seismic instrumentation in the country. The first seismological station in India was established in Calcutta, the place called Alibor, on December 1 in 1898 under auspices of Indian Meteorological Department. So, where the IMD was created, okay, in 1898, where they first deployed seismic station at Calcutta. Why those days actually the Calcutta, Chennai and Mumbai are the big port where lot of materials has been exported to the British government. So, this place they used to feel that this is very important to know the earthquake. So, that was there the Alibor region. So, during 98 to 99, okay, so in the short period of 1 year, the two more observatories were started in one at Bombay and the another at Kodaikanal. So, you may be worried that so what is the relation between getting the Bombay and Kodaikanal. So, if you see that the Calcutta was port, Bombay was the port, then why is the Kodaikanal? So, those days actually the British people, because as we know that summer we have very hot season. So, they used to go to take rest at Kodaikanal. Okay. So, those places they, so because of that hilly region, so they felt that some station can be kept there, so that whenever they go there they can also have guest house kind of thing they were. So, these observations are used by the Millen seismogram, which was developed in 1890s by the scientist Millen. We have seen that last class. So, after Great Kangra earthquake 1905, the seismological observatory was started in Shimla with Omari wing seismogram. This is another type of seismogram which was there in those days, but those instruments I am not very sure now it is available. So, you can see that up to 1900, so we have roughly about, okay, so 5 seismic station in the country. That means, from now 120 years back we had only 5 seismic instrument in India, and these instruments also kept so very far each other. So, why you need to have this knowledge? So, when you see some kind of seismic record, by mistake those people written that this earthquake was recorded on 1850, you should know that this earthquake is recorded or not if you know the history of seismic instrumentation in India. That is the reason. So, in 1929 the observatory was started in Agra, okay, with the Millen SAW seismogram. During 1930 2 more observatory was started, one at Dehradun and the another at Hyderabad. So, those days it is called Nizamiya. So, in Hyderabad. So, you can see that in 1930, so we had about 7 seismic instrumentation in the country. In south side there was one at Mumbai and there was one at Kodaikanal and one at Hyderabad. So, in the north Dehradun, Simla and Calcutta, these are all the north stations. In 1941 the Agra observatory was shifted to Delhi. Okay, so, even though it has been installed in 1929 in the Agra, but it has been shifted to Delhi in 1941. The number of observatory increased from 8 to 15, Okay, so increased to 8 in 1950, later to the 15 to 1960. That means up to independence we are having only 7 equipment. Okay, so then in 1950 there was a one more equipment is added, it is become a 8 after the independence. So after the independence then we added 5 more seismic instrument. In 1960 it is become a 7 more we added basically. So it become a basically 15 seismic instrument in India. Such a big country, you have the 15 instrument in up to 1960, okay, which is about 60 years back, okay, where the world was almost attained a modern seismic instrument during the 1960, and more sensitive instruments like Benioff and then the Sprenger Nether and Wood Anderson seismogram was added in the later stage. Okay, so that was the seismic instrumentation history. So that means up to 1960, okay, so we have only 15 seismic instrument. So among that there was a about 4 seismic instrument in southern India. So remaining were in North India, where there was a frequent small earthquake has been reported. Okay. So that was the status. So you can know that how the data before 60 is are accurate, how it is reliable. As you know that the number of instrument and spacing between the seismometers are very important to precisely predict a epicentral distance and depth of earthquake. That is what we have seen in the wave propagation. If you have the insufficient instrumentation, basically you will end up in the predicting the large error in the epicentral as well as the depth of earthquake. Okay. So as you know that using one seismic instrument you cannot predict a epicenter location, you can only predict a radial distance of the epicenter, that is all. So that means if any earthquake occurring at close to one seismic station may recorded there, but because of insufficient seismic stations the location predicted by these instruments are having the error. That you have to have the knowledge, because this is help in the hazard analysis interpreting the earthquake data what you have. You cannot blindly take some data and believe that that is 100% correct. So at present basically the IMD is the nodal agencies, okay, where the entire country network has been maintained by them. Out of the 4 stations, one at Delhi, one at Pune, one at Kodaikanal, one at Singapore, equipped with the sensitive seismogram under the worldwide standard seismogram network WWSSN, which we have seen during the last time. This is like a very broadband kind of things during the program of 1961. So you can see that. So the developed countries want to spy us, so they put the world global network seismic station at India during 1964. The national network is modernized, okay, with the 10 GS global standard network, digital instrument with the broadband seismogram in 1996 and 10 more upgraded with the broadband instrument in the 1998. You can see that up to 2000, okay, we have almost close to 35 equipments. Okay, so 35 seismometer in the whole country. So this upgraded observation high quality broadband data signal been obtained. In addition to that, IMD maintained few permanent small network like 6 station network in Delhi, 6 observatories in Punjab, Himachal Pradesh in 1965-66 and 3 Jammu and Kashmir in 1980s. This is to basically portable seismic instrument they use soon after the earthquake to monitor the aftershock events or something like that. So all these instruments being upgraded and digitalized. Okay. So then these stations are becoming a permanent seismic station to record data in the country. So there are more than 150 permanent standalone seismic stations around the country which was being maintained by the various agencies other than IMD. So they keep recording the data and independently now. So now there are plenty of seismic station, close to like 300-400 seismic station throughout the India is available, but however the station maintained by the IMD is actually the government controlled network, where those data are even now recently they started distributing to the public for research and development application. So until like 2020 there was no wide availability of earthquake records in India particularly. I mean earthquake record acceleration time history or velocity time history, not just a earthquake information. So what you are seeing is so much magnitude occurred at so and so place is a earthquake information, which will not so much useful for the engineering perspective or engineering application. There are many agencies who started operating their seismic station in the country. So we see some of them we really contributed to the national seismic data. So the first one is actually the Bhabha Atomic Research Center, BARC, Bombay. The most significant addition of National Network Seismological Station was established by the Special Seismological Array at Gauribindanur, which is very close to Bangalore, by the BARC in 1965 with collaboration with the UK. So this array is recording a small minor event. Conventionally seismogram is high sensitive and low noise. This main objective was, this array is basically to detect nuclear explosion. The India started its direction of research on the nuclear explosion kind of things in 1965, where they try to basically get study and monitor this kind of things for the neighboring country as well. So in 1988 the BRC also commissioned indigenously built analog telemetered seismic network 8 station and around Boston Dam, Maharashtra, to monitor reservoir induced seismicity. So this was done soon after the Koina earthquake. We will discuss the Koina earthquake in detail later stage. So after the Koina earthquake, the government in the mostly the people who are holding a big dam states are really concerned. So among that auspicious, the Mumbai basically Maharashtra state, they put a reservoir induced seismicity monitoring station under the BRC heading, there where they equipped all those things. So then the another person who maintain a seismic network in the country is actually National Geophysical Research Institute, which is NGRI Hyderabad, which is short form, many of you know that. So since it's established in 1970s, NGRI maintain a well equipped seismological observatory in Hyderabad. So it also set up a very high sensitive equipments, 3 component short period, 3 component long period seismogram similar to WWSSN. So where they try to monitor earthquake and try to delineate a seismic source, particularly for the important projects like a dam, okay, nuclear power plants, those kind of things they do. In 1990s, okay, the broad digital seismogram has been installed, observatory collaboration with the Geoscope France in the Hyderabad. Further, NGA was running a 6 to 10 station analog network since 1980s in Koina Dam for the monitoring the reservoir induced earthquake in the Koina, and then the network was upgraded digital later in 1990s. In addition to 1988, the NGI running 6 station analog and 16-bit digital telemetered standalone network in Dasapur, Assam and Northeast, and 16 digital bit system now upgraded 20 digital system early in 2000. So this NGRI also try to concentrate wherever the big earthquake is there, they deploy their network for a period of like 10 years, 5 years and try to understand the seismicity in the region, which will help for the seismic hazard prediction. So the regional research laboratory RRL Jordan, Assam, the northeast region. So they try to establish 4 vertical component short period seismogram. Okay, so progressively since 1890, you can see that you can see a single axis seismogram has been used in the Assam. It's a vertical component. That means it doesn't record a horizontal component. As we have seen that even though the vertical components are not very much important in the wave propagation, as you know that the vertical component will be only predominant when you have the close to the P wave arrival region or deep earthquake. Out of these 6 stations were running analog and 16-bit digital telemeter. 16-bit digital system was upgraded 24 during the 2000 and 3 more broadband were established. Okay, so in the epicenter area, great earthquake of Shillong region in the Assam RRL people. Okay, the RRL people established network close to Shillong earthquake region and try to monitor the seismic activity in those regions. So similarly in Dehradun region, the Waldia Institute of Waldia Institute of Himalayan Geology, so try to establish seismic station at a greater extent and try to monitor earthquake in the Himachal region as well as the Garhwal Himalaya. The 5 station 3 component short period seismogram one. So these are all the basically regional network. You can see that they used short period sensor, some of them used 3 component, some of them used a single component. So similar to that, there was a Vadodara, Gujarat, okay, Gujarat Engineering Research Institute. So GRI running a permanent seismic station at Vadodara, Gujarat. GRI also associated with most major and medium irrigation project at Gujarat. This project run 5 to 6 seismic station with a short period seismogram digital network. So most of the people when government started funding the seismic station support, most of the people they try to establish depending upon their institute in and around as well as the facilities what they have in and around. So some of them like dams and the geophysical research institute like that. So in there is a institute started, okay, after 2001 Bhuj earthquake, which is called the Institute of Seismology Research, ISR Gandhinagar. So where they started running some stations in and around Gujarat, particularly Kutch region, where 22 broadband seismic stations are operation, and the region with the central recording station of Gandhinagar, capital city of state, about 10 strong motion also installed. So these are all the places they installed and try to monitor earthquake and try to understand where the earthquakes are occurring. So similar to that, the Maharashtra Engineering Research Institute, they also maintained 30 seismology station, different irrigation project. The seismic stations also functioning in headquarters Nasik. Most of the stations are vertical component, short period, smoked pepper seismogram. This Maharashtra one may be the very outdated old seismic. Then similarly Kerala State Electricity Board Kottayam, so run 12 seismic stations around Idukki dam site, northern part of Kerala state. Each station is short period vertical seismogram. Then the Central Water Power Research Station Pune, CWPRS Pune. So look at 2-3 permanent analog micro earthquake network consisting of 2 to 3 seismic station each work on the eastern Himalaya including Sikkim and Bhutan for the water related project. So the Center for Earth Science Studies, CES Trivandrum, so they run some earthquake station close to Trivandrum where the southern India, so some of the stations are operated. So IIT Roorkee, they have taken a big initiative where the Department of Earthquake Engineering IIT Roorkee runs 6 station telemetric analog micro station network around the Terry Dam, Garhwal Himalaya, and network was upgraded to digital and try to monitor. They try to establish a big network in the Himalayan region about 5 years back. Then they also hand over that to the IMD followed by that. So similarly the University of Delhi, they try to monitor some earthquake in and around Delhi and installing the so seismometer, short period, long period, and Manipur University, Impal, they try to install some station in and around their region, try to monitor earthquake. So even the IIT Kharagpur, okay, they install and maintain some station in the Sikkim, part of their seismic microzonation of Sikkim city. So there are other institutes where run like Kurukshetra University, Andhra Usmania University, okay, then Dhanbad Bihar State, Banaras Hindu University, Uttar Pradesh, and then Guwahati University, IIT Guwahati, Mizoram, okay. So even IAC has a some kind of seismic station installed and maintained. Okay, so if you see that the country has tried to establish a seismic station after 90s. So you can see most of the seismic station where they start installing by the time the world was got very advanced seismic instruments. Okay, that is what we can notice, and most of the instrument what you can see that many of them are having a vertical component, which is according to me basically which is not so much useful for the understanding the wave propagation, as you know that some of the wave may not be completely represented in the vertical component seismometer. So this was the status of seismic instrumentation in the country, but now as on all the permanent stations, okay, will be controlled by the IMD, Indian Meteorological Department. So where they basically upgraded many of the old station and try to record the data and try to report to the universal values rather than this one. So, there was many place where they start seismic instrumentation and establish, after that there is no maintenance and report. So, as I can say that until 2020 India has very limited access to the earthquake recorded data such as acceleration time history, velocities time history in the old earthquakes because of poor and improper management of the seismic station in those days. So, with this we will close, we will go to the IMD seismic stations in the next class. So, thank you.